hosted by Fiber Connect Council MENA. Our extends to our members and their partners, and we hope all of you join our webinar and our council and benefit from today's webinar. I would like to thank our council member, Cross Network Intelligence, as well, in accepting our invitation and presenting today's webinar with an expert speaker talking about solving the telecoms network data challenge, Mr. Harinder Bakhshi, Director of Solution Architecture at Cross Network Intelligence. Mr. Hari is a technical leader at Cross Network Intelligence. He has a bachelor degree in biotechnology and a master's in network technology and management. He's spent time with a well-known operator building mobile networks, and he has both sales and delivery experience with equipment and software vendors. Mr. Hari drives technical engagement with international customers. Mr. Hari is interested in building the most efficient operational management platforms and using analytics, BI, workflow, and a single network inventory to get there. Despite, or perhaps because of 25 years in industry, Mr. Hari still enjoys the challenge of change that characterizes telecoms as it expands to include IT and virtualization in the network. For all our attendees, please note that Mr. Hari will answer your questions once he finished the presentation. Mr. Hari, I'm very happy to welcome you today. Please have the full floor.
Thanks for the introduction, Khaloud, and thank you to all the attendees for being here today. Again, my name is Harinder Bakhshi. I'm the Director of Solution Architecture across Network Intelligence. And today I'll explore a topic that's shaping the future of telecommunications. When we talk about digital transformation, automation, 5G, artificial intelligence, you have to remember that all these advances have one thing in common. They require network data. And more importantly, they require the data to be visible and accessible. Achieving any meaningful update to a network's operations requires an operator to take a hard look at their inventory and network data first, and make sure that the underlying foundations of the OSS/BSS stack is robust. The challenge is that with fragmented systems, hundreds of spreadsheets and databases, and thousands of datasets, it may seem unrealistic to consider any sort of overhaul to the data architecture. That could be seen as expensive, time-consuming, and risky, but it is necessary. Thing is, it does not have to be expensive, time-consuming, or risky. So during today's webinar, I'll be exploring some of the core data challenges faced by almost every telco and the safe, flexible ways that they can be addressed. I'll show you what it looks like in a live demo of our flagship product, Cross, and then I'll share some use cases where this applies and the benefits that can be achieved. We'll wrap up with a summary of who we are and then move on to Q&A. Before we start, I'd just like to be clear. The company is called Cross Network Intelligence, and the product we'll be demonstrating is called Cross. So I'll just leave this agenda up for a second for you to read it, and then we'll dive straight in. Okay, so where are we now? Well, we're in a situation where the inventory and network data is often fragmented. It's often in many places. So most telcos are in the situation where they have data, they have lots of data, but a lot or even most of that data is hidden. So what we're talking about is illuminating that data, making it available in one place for operations, for BSS, and for automation. So a typical environment, an operator might have a service inventory that's at a BSS level. And then they might have, for example, a physical inventory. So for working as a PON provider, then you'd have a physical inventory on a geo map. Then there could be a logical inventory. So the NMS systems would have a logical inventory. And then there could be logical and active physical components. And these are all held in separate inventories. So it makes it quite difficult to run automation, which requires a little bit of each inventory. So in the future, telecoms need the data to be accessible. So all the information from the BSS, from the OSS and NMSs, from the network needs to be available to the user and to operating systems. It needs a single point to hit to be able to not just take information but give direction as well. So the lack of one of the key impacts of a lack of a single network view is on operational cost. Quite often, telcos have legacy systems that may be coming to the end of their life. One of my customers has a very significant database that they need to replace. And the reason they need to replace it is the people who maintain it, the people who wrote it, are 65 and they want to retire. So while this company has plenty of people who can use the system, it has pretty much no one who can work on the system, who can develop the system, and it is a core system. So that's one system that we at Cross Network Intelligence are trying to replace. As well as legacy systems, most telcos have their data in silos. So you could have a logical silo, you could have a physical silo. In fact, you probably have multiple logical silos. You'd have one, say, for MPLS, one for layer 2, and then you could have another logical silo for PON or for WDM. And this information really needs to be shared when you're setting up a customer service. And remember, the service is what generates you the revenue. The service doesn't care about all these underlying layers. But at the moment, we make the service care because a provisioning action has to involve elements from all these different data silos. So this means that there's no single view of the network. There's no cockpit view. We call it a single source of truth, a cockpit view, a single pane of glass. I mean, these are all the words around it, but it doesn't exist. In addition, you can have silos because of merger and acquisition and expansion. So company A might use an Alcatel WDM network. Company B might use a Cisco WDM network. They're both WDM networks. They both follow the same ITU standards. They're interoperable, but at a management level, they don't connect. So that's another issue that needs to be dealt with. So most operators will actually face a combination of these. They will have legacy systems, and a legacy system could be Excel. It could be we've done everything on Excel, and now that's just dominating. We can't get away from it. And it could be the data silos. So these provide complex challenges, which I'm going to take you through a way of solving, and I'm going to show you that in the demo. This is a quote from AT&T. The data challenge is around integrating information from multiple systems all in a single place. So it's that single pane of glass, it's that illumination, it's that single source of truth. So now I'm going to start talking more about our software. So as I mentioned at the beginning, the company is called Cross Network Intelligence, and our flagship product is called Cross. It's enhanced with a few microservices, some of which I'll mention later. But fundamentally, when I say Cross now, I'm going to be talking about our software product. So what Cross does is it integrates multiple inventory sources. So anything that can be programmatically ingested or manually input into Cross. It does network discovery by integrating periodically with the NMS to find out not just what's in the network, but its configuration, its software, its IP address, its firmware versions. It pulls all that into one place, and it makes it available for processes. Typically BSS processes, but this could be other OSS processes as well. And what's the benefit of doing all this? Well, firstly, you save a lot of time and a lot of money, and primarily that's in OpEx, but there is a CapEx saving as well. But you save a lot of time. You have a platform for automation. So as you move to a situation where you have more products you're offering or more services and you want to take more customers, then automation becomes very important. And it provides a platform for BSS automation. And it allows you to provide for future growth. So where you have a documented system and a single source of truth, when you expand or when you acquire, you can pull that information in and combine that to maintain that single source of truth for BSS and OSS operations. You don't have to keep running separate systems. So I keep saying a single source of network truth, and that's what we are, the single pane of glass, the cockpit view. What we do is we consolidate. We create a unified inventory of the network in Cross. And I'm going to mention this several times, but the key feature of Cross is it vertically integrates inventory. So if you have a service, an IPVPN or a VPLS or a VLAN service at the top level, you can vertically slice through the network, and you can see which pseudo wire, for example, it runs on, which MPLS tunnel that's in, which layer 2 Ethernet circuit that's in, which optical circuit that's on, which fiber runs that, which fiber bundle, which trench, which patch cables. All of that is visible. So that means that you could select, for example, just a patch cable, and in Cross you can see every service that runs across that. It saves a huge amount of time in troubleshooting and also in looking at service impact analysis. So, if I have planned works to do on this trench, who's it going to affect? Well, Cross will tell you straight away. You can use Cross to improve the data accuracy. Cross does not require you to provide perfect data, but what Cross does give you is a mechanism to improve the quality of the data you have. So, as an example, if we have a fiber cable that runs from building A to building B, we can say it just runs building to building, and that's what we call level 5 data. We don't know the exact patching or connectivity, we just know it runs there. If we have a fiber from that cable, which we know where it terminates on an ODF at both ends, well, that's all possible information on that object, and that's what we call level 1 data. Now, we can start with level 5 data, we can create reports, and we can help you improve the quality of the data, so you get to the point where you have that level 1 data and you know all possible parameters. We can also link this with automatic updates from EMS and NMS. And then we create this platform for automation. Because we have that single source of truth, we create a single hit point for BSS systems to come and ask, tell me about this, and then for them to say, right, I want you to create this. And what Cross will do would, for example, be to trace a circuit. It would then reserve that circuit, and also it would output to workforce management or a work order elements of the circuit that are missing to allow them to be filled in. As they're filled in, we will get the automatic updates, and then we can declare the circuit ready for service, and it can go into service. So traditional solutions, which is pretty much how it's done now, are reasonably straightforward to implement. So when you buy a logical network system from someone, Cisco or CNO or anyone, you will get the management system for that. And it'll show you what you need to know for that logical system. What it won't show you is the interconnection between that system and other systems from other manufacturers. And what it won't show you is the top level services that are running over, or the underlying providers, the underlying resources that provide that network. It's a pretty good solution, and we have there are plenty of companies in the industry that will offer a federation of this data. So they'll create a map and they'll put a layer on which is a physical layer, then they'll put a layer on which is a logical layer. So where you have co-location, you can see, right, so this logical circuit goes between these points, and I can see there's a physical circuit underneath. So you can imply the connection. What Cross does is it goes one stage further. It actually explicitly documents that connection. So Cross integrates and documents all possible or all available information. Now, we can either take that in programmatically, and when we do that, we use a system called Syncro, or you can add it manually. And we have customers who have very simple fiber networks, but very complex service overlays. So the fiber network is put in manually, and the service overlay is read in programmatically. But that's not typical. Typically, we read in the physical layer as well as the logical layers. So the system we use for doing this is called Syncro, and it's a microservice within Cross. And what Syncro does is it manages the input of the data. So it has, for example, a delta check. So as data comes in, it'll check, does that data exist? Do those objects exist in the database? If not, it can add them. And then it does something very important called cross-domain mapping. So if you take a typical object like a router will exist at layer 3. It'll have IP addresses and it'll hold service connections. It'll exist at layer 2. It'll have Ethernet connections, and it could be Ethernet pseudo-wire connections. And it'll exist at layer 1. It'll have a physical port. So we do this system called cross-domain mapping, where we take an object and we map it into the domains where it's needed, where the layers where we need to see it. And that's really sort of one of the heart processes, one of the core processes in Cross. It's one of the core bits of our intellectual property. So we read data in from external sources, and then we will map that against our data model called datex. It's that data model which is based on ITU standards. So ITU standards for SDH, PDH for radio, for Ethernet, for MPLS. We build that data model internally from this external data. Now, in order to do that, Syncro runs connectors and probes. And these connectors and probes are bits of Java code which effectively give each probe or connector its personality. So what they do is they say, right, this is the external data. And that external data could be Excel sheets, it could be databases, it could be flat files, XML, JSON. It could be, anything programmatically readable, and those probes, that bit of Java code, that personality maps that information into our data model. Now, where this is something permanent, for example, if we were to do a connection to a GIS to, say, small world PNI, then we tend to call it a connector. Where it's something where we're talking to an NMS, where we maybe do some configuration work to the probe to make it fit for a particular customer, then we tend to call it a probe. But it's the same thing. It's how we ingest that data. Now, we run these probes typically for GIS, we'd run them daily. For NMS, we might run them more often. If there is a requirement for real-time data, then we can either ingest that through our Open API version 3 REST APIs, or we can stream them in and then read them through the APIs, and we typically stream through Kafka. So we have quite robust methods for synchronizing the data, for pulling the data in from the multiple sources and presenting them in one place using our data model. I've talked about data quality. And again, that's something as the data is ingested, it's tagged. And we currently have probes for more than 30 NMS systems, and we have connectors for things like GIS. Oops, I'm sorry, I've gone too far. Let me go back one. There we go. So in doing this, we again come back to this single source of truth about the network. We're integrating everything, and then we're doing this vertical connection between layers. So this IP service runs on this layer 2 service, runs on this physical service, runs in this trench. And you can see that immediately. Now, I used to work in a NOC, and if we had a failure, in order to trace the failure end to end, and I used to deploy mobile base stations, LTE base stations, to trace that failure end to end needed us to go into 4 or 5 systems. And to be able to work through either Ethernet or PDH, then the fiber system, DWDM, and back up the other end into the IP space. Now we can pull all of that together and massively reduce the time required to troubleshoot and to understand your network. We're multi-vendor and multi-technology. We don't really care who the vendor is. Pretty much every vendor will work to a certain set of standards in order to maintain interoperability. So we don't care who the vendor is. We care what the vendor does and what the equipment does. And by doing all this, we support core processes. So we, for example, do capacity management, and we do capacity management across the whole spectrum of the telecom world. So we can manage power capacity, air conditioning capacity. We can assign a power and air conditioning capacity to a building or a room. And then as every child object takes power or air conditioning, we can take that away from the capacity so we can show the remaining capacity. And that's capacity management on a very big physical things. But then we can also do that on trenches. We can say this trench has a capacity of this many cables. And as cables are added to the trench, we can take away from the capacity. We can do it within cables. This cable has 16 fibers. As those fibers are used, we can take it away from available capacity, and so on upwards. So we can have a 10 gig circuit, and then we track how much of the bandwidth is used on that circuit, and you can run reports on that. So that's capacity management. We do root cause analysis as an option. We can accept alarms. And what we do is we take the alarms, and I'll show you this in the demo. We take the alarms, we map them to a fault tree, and we say, right, what is the root cause fault? Okay. So now I'm going to switch over to the demo. So if you give me one moment, I just need to change screens. Okay, so let me go up a level. So now we're looking at across the software, and this is the dashboard, this is the landing page. Now, what I'm going to go through in this demo really is location, circuit, a little bit of the insight module, and a little bit of service impact analysis. There are other modules I'm not going to discuss, like the IP pooling, the material module, and the material module is very interesting. That's where you set up all your standard materials. So if you want to manually do something, or if you want to create an environment for automatic provisioning, you don't have to set up the material every time. You just say, I want this material. And we've already talked about Syncro. So let me jump straight in to this location module. And what we can see here is an exchange, and then some homes. And this is a PON. So first thing I should do is switch on some layers. And now I've switched on the layers, you can see the connectivity between the exchange, and this is PON 1, PON 2, and PON 3, and all the homes that are on that PON. Now, what's interesting about all this information, so the trenches, the cables, the actually the end devices as well, the ONT devices, these have all come from a GIS system. In this case, it's GE Small World PNI, but it could be any other GIS system. Excuse me. And they've been imported into Cross, and they're maintained every night. It's kept up to date. So we don't have to put all of this in. We could do all this manually in Cross, but we don't have to, because we're integrated with the GIS, and through Syncro, we pull in all the relevant, well, actually not all the relevant, all the physical information. And I can show you that in a little bit more detail. So if I go here and I type extra exchange, here we've got that exchange. And as I expand it, we can see the different elements that are inside it. So we've got elements here like the ODFs, which are physical, and these came across with the data input from GIS. And then we show them, and we can work with them. We can also look at, for example, the fiber welding. So we can go here and we can say, show me the optical welding. There's patch coding or welding. And then that'll take us to a screen where we can see how the cables are connected. And again, we haven't done this. So on this side, you can see the fiber, and you can see where it's connected here. Now, we haven't manually done this. This has been imported. So these are all those are the physical components we've imported in. But then on top of that, we've got logical components. We've got DSLAMs, we've got OLTs, and we've got an IP rack. And it's the IP rack and the OLT that we'll be talking about more. Within the map, you can actually see some interesting things. So this yellow blob here, that's a splitter. So that's a first level splitter. Then there's another one here, which is a second level splitter. So we show the splitter part as well as the physical network. Now let's look at perhaps something more interesting, and let's go logical. So what I want to do now is look at the PON path. So we have a PON path here going from the exchange to number 17. But I want to know more about the PON path. I want to know the route it follows. And so what I can do is open the PON path as a circuit. And that switches us into the circuit view. And here you can see the start point and the end point, and you can see the PON path is made up of 3 PON links. And on the map, we can see those 3 PON links. But I want even more information. I want to know the exact path of this PON link. So that's easy. What I do is I go to this PON link and I say expand all. And now I can see the exact path of that PON link, and I can see every cable, every patch underneath. If I wanted to see that for the entire PON path, I can expand all, and now I see the entire PON path in the map, and then it's documented here. Every trench, every connection, every cable, every port, everything else. Now the other thing I can do is I can right click at any point in this hierarchy. Let's do it down here. And I can say, show me the services. Now we've only set up one service, but this is the service that's running on that trench. Now at any point in this hierarchy, I can do that. So I can say patch cord, show me the service. And it'll be the same service because we only have one. If you had 100, they'd be at 100 listed here. But there's that service. So it shows you for any object at any level in the hierarchy within the network. First of all, it shows you where that object is. And then it tells you what services are running over it. Now, the other thing we can do, let me go back. Sorry, I need to go here. Then look at consumers. What we can see is the consumers of that PON path. So what's consuming the PON path? In this case, it's an Ethernet circuit. So I can make that my main circuit. I can set that as a header in the routing. And it's a 300-kilometer Ethernet circuit that goes from the house that we looked at all the way over to an exchange in Basingstoke. Now, if I look at the schema here, it's a very simple schema. I can see the Basingstoke exchange, I can see the Exeter exchange, and I can see this house. So there's the remote exchange, the local exchange, and the house. But maybe I want to see more. Maybe I want to know what's going on and what all the connections are. Well, that's easily done. If I again say expand all, and then go to schema, I now see the full path. I see everything that's in the path. So there's the Basingstoke exchange, there's the Exeter exchange, but I also now have the PON. And I have all the underground routes, I have all the connections, I have all the splices, and this is a splice point here, all the way up to another splice point, and then the home, the final location. So I can fully document this connection, and the system will do tracing. So we can trace the PON connections. By trace, I mean you put in the endpoints, put in the 2 endpoints, and say, right, build me a circuit and show me the circuit. So you don't have to do that manually. The system will create those circuits for you, and it'll fully populate it with all this information. Now, the other thing we can see here is these thick red lines. Now, these lines mean that there's an alarm on the system. Now, we can look at this and say, okay, so there's this one, oh, this is the root cause. This has to be the root cause because it's the lowest level alarm. And that's great if you're looking at one. But if you have, most operators have thousands of alarms a day. And if you have a lot of alarms and you want to do a root cause analysis, we have a module for it. And it's called Service Impact Analysis. And let me show you that next. So here is that alarm, and the system has decided the root cause is that underground route 77809. This one, 77809. But what the system also does is it tells you the service is affected. And there's that test service we saw before. And if there was 100 services, there'd be 100 listed here, and you can export them. It shows you the impacted services, and it also shows you the sub-alarms. So it's saying this root cause alarm has caused these sub-alarms. So that's the way we can use this fully integrated database, the full vertical stacking to do root cause. We don't do it based on time. We do it based on, the actual map, the graph of the schema graph that we have here. Okay. So the only other thing I really want to show you here is the Insight module. And I'm going to go to that with this Ethernet circuit. So this is a Ethernet circuit that runs on IMPM, partly on the PON and partly on MPLS. And I'm going to go to Insight. Now, Insight is one of the most useful modules in Cross, and it's also one of the most time-saving. And what the Insight module does is it gives you a 360-degree view around any object in the Cross database. So here we have a link object. You can also have node objects, which I'll show you in a second. And for a link object, which is that Ethernet, we can see the start point and the end point. We can see the providers and the consumers. Now, this Ethernet service is a top-level object, so it has no consumers. But if I was to click on this Ethernet object, this is local at the extra exchange, and it's actually the connection between the OLT and the router. And it has a consumer. Its consumer is that Ethernet GPON. So you can navigate around the system in this way. Now, we've looked at links. Let's look at a node object. So this is a node object. It's a port. It's at lowest level, so it has no children. It has a parent, which is a card. It has a routed link. So there's a link that routes across it, which is the end-to-end Ethernet GPON. But it also has a terminated link. So this port terminates an Ethernet circuit, and it's that circuit that goes to the OLT. Now, we can navigate just by clicking through the hierarchies. So if I get to the building becomes a central managed object. Its parent is a location, and its children are all the racks and equipment that are inside it. We can see the routed links that route through that building, and we can see the terminated links that terminate on that building. And this is Insight, and this gives you that 360-degree view around any object. And this in itself is a huge time saver because it gives you those connections between links, links and nodes, and it also gives you those connections between logical and physical services. And it's all available in one place. So I think that's all I wanted to show you at the moment. Obviously, this is a very, very quick look through Cross. There is much more to it. We could, for example, turn on Ethernet links and see Ethernet links, and then we could click on this one and choose it, and that would take us to this circuit. So the other thing to understand about Cross is everything is connected. So it doesn't matter which module you're in, you can move to a different module. You can follow the connection. So if I had this Ethernet link and I wanted to go to this PON connection, I could click on the down arrow and just say, take me to the location module. And now it'll switch to the location module, it'll highlight the location, and it'll show me that port and its place in the hierarchy. So this is the home, there's the sheath splice, and here's the network element, the PON and there's the patching for it. So because these are connected, you can see this little circuit icon. This means, well, this object in the node inventory is connected to a link. We can again go there and we can say, show me the circuit, which will take us back to our original circuit. Okay, so thanks for listening to that. I'm just going to go back to the presentation, if you can give me a moment. Okay, so that's the demo finished, and we are back to our presentation. So what does all this mean? Well, it means that Cross as a software and Cross Network Intelligence as a company can boost operations and help your business. At the end of the day, this is a business, it's there to make money. So the way to make money is to keep your costs low and maintain your revenues high. We do that by consolidating the available information. This information exists. This isn't new information or magic information. This is information that already exists in your network, but it's typically invisible, and we can illuminate it. We can reduce OpEx and contain CapEx. Actually, I think that should be the other way around. It should be reduce our CapEx and contain OpEx. No, it is right. It is right. Sorry, I'm being a bit hard of thinking. It is absolutely right. So we can reduce OpEx by being more efficient. And I showed you in Insight how you can easily trace connections, easily see how things work. We can do planning. We can, plan those we can plan those PON connections, and then we can create an output which says, right, this is the work that needs doing to do these PON connections. Send a guy out with a van and a load of fiber cables and do this patching. And we can do that level of planning. We can do tracing. We can do tracing at fiber level. We can do tracing and tracing is creating that end-to-end connection over the available resources. So we can do tracing at fiber level. Then we could trace a PON circuit over that fiber. Then we could trace an Ethernet circuit over that. We could trace an IP/MPLS circuit over that. So we can do that level of planning. We provide that single hit point for automated BSS workflows. So a workflow in BSS, instead of having to go through to multiple systems, all of which have to be separately maintained and the interfaces have to be maintained, can use our OpenAPI version 3 REST-based API to talk to Cross to get that information, and also to provide instructions to say, do this tracing, do this action. Doing all this really minimizes the time it takes to provide a customer service. So when a customer orders a service, the time you take to deliver that service is dead time. You will never get the revenue for that. You can never recover it. So if you can deliver that service faster, well, that's more revenue. You can look at the network and say, right, I'm going to do planned maintenance at this exchange, and you can see who it will affect. So you can either divert them or you can warn them at least. And you can see where a fault affects a customer. And we can work with existing levels of data and then work with you to make them more accurate, to go from level 5 to level 4 to 3 to 2 to 1. Now, Cross also has a number of tools built in, which once you've read the databases in, once you've read the inventories in, you can use these tools across all layers. A really good example of that is IP address management. So we have IP pools inside the tool. Now, you can use those pools across all layers. So if you have a layer 1 device, which just needs a management address, well, that can come from the pool. If you have a layer 3 device, which needs endpoint IP addresses for an IP link, well, that can come from the pool. We do the capacity management, which I explained earlier. We also do the service impact analysis, which I showed you. And these are done, these don't care which layer the object's at. So we can do the capacity management for air conditioning and power. We can also do it for virtual circuits. Excuse me. We've talked about service assurance and, of course, analysis. Lease lines is an interesting one. We can separately tag leased resources and owned resources. So you may own your own fiber network, but also lease some circuits. And we can show those on the map and also through a microservice we have called Checker. And you can see where your leased, for example, a leased resource runs very close to an owned resource. So can you use your own resource instead and terminate the lease, save some money that way? Now, Checker is a lighter version of Cross, and it's more intended for front office users. And what Checker does is it takes the database from Cross and any other system. It's not just restricted to Cross. Any other system that has geo coordinates, and it shows those on a map. So when someone phones in, or if there's a query, Checker, you can look in Checker and you can see, right, I have a point of presence, or I have a service here, or I have a fiber passing. That's one of the microservices we offer. And then Cross acts as a bridge between cost and revenue. So your network is your cost. That's where you have to invest to, create the resources. And your BSS side is really the revenue. That's where you take customers in, and that's where you build them. How do you connect the two? Well, Cross is that connection. It's that weld between the two. We can provide reporting upwards and reporting downwards if there's another OSS that wants it. We can work on fulfillment, documentation, assurance, and alarms, which you've seen. And we provide that single hit point for the BSS to come to and ask for information. And then we can also provide information back out, for example, in ticketing or workflows or work order management, and say, you need to go and do this bit of patching. So very importantly, Cross is that bridge between the revenue and the cost between the OSS and the BSS domains. And this is one of the ways, just an example of how we would support a BSS workflow. So you've got the third-party BSS, which typically contains CRM, service catalog, workflow, work order, that sort of thing. And you've got Cross, which owns the resources. So there'll be service inventory, a resource inventory, all the network side stuff. So you could have a service request, and the first part of that could be give me an address check. Do we serve this property or do we serve this location? Cross goes and checks, it comes back, yes, it does. And the next part of that could be, okay, I want you to trace a circuit from that location back to the exchange so I can provide service to that customer. Cross will do that, and its output would be, maybe just a yes, everything's in place, but it could be a work order. And it says, okay, in order to do this, you need to make these connections. So you need to patch here and patch here. That goes off, it's done, and then Cross gets the information back and it shows the circuit in service. And the circuit is activated and starts earning revenue. So that's how Cross will work with BSSs. High impact results, the benefits, well, reduced time to market, we've spoken about that. Dead time can never be recovered. So if you can provision quicker, you can make more money. We can optimize resources and services. And we act as that bridge between the service layer and the resource layer. Reduce our OpEx by just making the information more available more quickly, allowing your service teams to do more and to do what they're doing more quickly. We provided a level of future proofing because once you have the inventory in Cross, if you then need to add a separate inventory from an acquisition or a merger, you can do that. And once it's in, it will work through the same APIs. So it just makes that joining, connection, and interop much easier. So what are the OpEx savings that you can expect? Well, we talked about lease line optimization. Why pay for a lease line if you have a owned service? So we can do that. Because we do illuminate how much energy is used, we can work on saving money on the energy side. And typically this could be things like do an audit and find there are old ATM devices or Nortel passport devices that are still connected and taking power but haven't passed traffic for 10 years. We can help identify these things through reports. And the main one really is, one of the biggest ones is that working in the NOC, working as an operator. The time to identify time to identify a service impact on a customer is massively reduced. And the ability to plan ahead and say, right, doing this will affect these customers really, really saves money. Okay, so it's the summary slide. I'm not going to read it all because you've just listened to me say it all, but fundamentally we can integrate all available data and improve its quality. We can correlate and consolidate. We act as that bridge between the revenue and the cost, the BSS and the OSS. We massively increase operational efficiency and reduce costs. We take data which previously was hidden and make it available. And we are, providing that single source of truth. And again, I just want to finish the way I've started. The key thing about Cross and the unique thing about Cross is that vertical alignment where you go all the way top to bottom and you understand and you can see exactly what's there and you can operate on that. You can work on that. You can query that. You can set up tracing on that. So at that point, I'm going to say thank you for listening to me. I'm going to stop and I'm going to hand over to my colleague, Mihail.
My name is Mihail Botez, and I am the Partner Relationship Manager at Cross Network Intelligence. I will conclude today's session with a few words about who we are and where the idea behind Cross came from. Cross Network Intelligence, the company behind the Cross software, was founded 7 years ago by a group of experienced individuals, software engineers and former senior managers who worked for the technology companies that either created or implemented the leading telecom enterprise platforms in the past 30 years. And you have them listed there. And that include companies that dealt with outside plant, inside plant systems, usually CAD or GIS based, dealing with the technical aspect of the inventory, and the OSS and the BSS, more business-oriented solutions. Our founders' experience with multiple technology platforms gave us the opportunity to spot functionality gaps in the available software offerings and also to address their foundational limitations, and in the process to align a new solution with the new software technology trend. Next slide, please. So around 2010, while we were working with few telecom operators in Central Europe, we decided to go back to the very foundation of any software, which is the data model, meaning the abstract computer model that organizes elements of data and how they relate to one another and to the properties of the real world entities, in our case, the network assets and the network topologies. And that's how Cross was born, from inventing a 5 tables data model of network assets, dealing with both the what they call horizontal topology, reflecting the physical assets connectivity, and the vertical topology, reflecting the services and the network capacity. This 5 tables data model is actually the meaning of the 5 rectangles that you can see in our company's logo. Our software fresh approach to the old challenge of how to model network topologies was immediately recognized by network operators, mostly traditional telecom service providers, but also a few public and utility service providers. Caught the attention of system integration and integrators, and last but not least, the attention and interest of investors. And this gave us the chance to rapidly expand our presence and the installed base in the rest of Europe, Northern Africa, and recently to the Middle East. Next slide, please. Our early adopters helped spread the word about Cross. So though we're a new and relatively small company, Cross unique features briefly introduced to you earlier by my colleague Hari attracted the attention of a handful of software vendors such as General Electric and Bearing Point, and of solution providers such as Real World Systems and Engzo, just to name just a few. For those in the audience interested to partner with us, either as complementary solution providers or as solution delivery specialists, our experienced team is ready to support you with training and support, and with our data and process integration methodologies in order to deliver robust and fast solutions to your customers. Next slide, please. I will conclude by expressing how grateful and proud too we are of our customers. Binet of Bahrain is of a special importance with us for us, not only because of being part of the MEA region, but also because they entrusted us to implement a solution of a business critical importance for their new charter as a nationwide fiber broadband network, even if our company was not present in the region with a physical office. BNet was deployed with both OSS and BSS built on Amazon Web Services, integrated with its network management systems and the GIS data coming from Batelco. Using cross capabilities to unify legacy systems and data silos while dealing with existing data of variable quality. BNet was capable to bridge the OSS and BSS worlds, to correlate the cost with the benefits as explained by Hari earlier, and in the process to improve the operational processes and procedures for its national fiber broadband network. Next slide, please. So many thanks to all attendees for joining us today, and please do not hesitate to check our website and to get in touch with us via email or via the contact form from our website. So back to you, Khulud, and to Hari for any questions that may come from the audience.
Well, thank you very much, Mr. Mihail and Mr. Harry, for this very informative webinar. And I want to thank all the attendees. Please, if you have any question that you would like Mr. Harry or Mr. Mihail to answer, don't hesitate to type it in the chat area. There is one comment from Dr. Singh. He was stating that data challenge, especially in wireless network, rather fiber optic. I guess he was commenting on one of the slides while the presentation was on. And if anybody has any question, please type in the chat area.
Sure. Let me just deal with the issue of data. We do have radio. We do have a radio module, and the presentation was mainly focused towards fiber, as this is the Fiber Council. But one of the key areas we're operating in is where you take fiber up to a base station, and then you want to also document the base station. So we can document the base station inventory, whether this is old-fashioned BTS where the aerials are all at the base station, or newer models where you have a base station, then you have front haul CWDM, and then you have antennae dotted around. These can all be documented in Cross. We can act as a repository for frequencies, and we can take coverage maps. We don't create coverage maps, but we can import the coverage maps and show them in Cross. So we can provide an integration not just with fiber, but with the radio space as well. And included in that radio space is microwave. So where you have microwave links, microwave rings, we can document that, we can show them as a layer, and we can build that in to the overall infrastructure, the overall network infrastructure.
Okay, thank you, Mr. Harry. Anybody has any question, please? All right, so I believe nobody has any questions. So at the end, I can only thank you, Mr. Harry, Mr. Mihail, and Mr. Peter also, who organized this webinar from Cross Network Intelligence, for this webinar and for your time. And we hope all the attendees enjoyed and learned as much as I did today. Looking forward to welcome you all of you in our next webinar. We will announce all the details soon. Sorry, there's a question from Nader. Can we get the status of connectivity, or if failure happen on our connectivity will be reflected?
Yes, so Cross is not a alarm management system. But what it does is typically an operator will have an alarm management system, and it can output the alarms on topics. And what Cross can do is subscribe to those topics and pull the relevant alarms in. And yes, those will be reflected in Cross with alarm details, and it'll do the root cause analysis. So you can get the status of connectivity reflected on alarms that are reflected via alarms. So where you have a connectivity loss, which creates an alarm, we will show that.
Great, thank you, Mr. Harney. I guess someone else also is typing. Thank you, Lino. They said it was informative. Thank you so much. Thank you for joining. Thank you, Nader. Thanks for all attendees. It was really a great webinar. Thank you, Mr. Mihail, Mr. Harry, for joining us today. I wish everybody enjoyed this webinar and looking forward to welcome you all in our next webinar soon. Thank you so much, and have a lovely evening in the Middle East and a great day ahead in Europe and US. Thank you.
Thank you very much. Thank you. Bye-bye.
Bye.